Welcome, welcome, welcome to our next lesson on the multiplication properties of exponents. If we look at this next slide here, this next slide is going to help us out with our multiplication properties of exponents. It's kind of going to give us a quick understanding of what happens. We have a few different properties. This will be the first one here. Let's look at this. You just watch this part. You don't have to write anything down. Just watch and listen. If I take a cubed, what does a cubed mean? It means I have a times a times a. That's a cubed. Now, if I take, let me put that multiplication sign. I know that looks like an asterisk, and it is an asterisk, except the program that I have to type this up on will not allow me to put a dot in there for dot multiplication. So I put an asterisk in there, and sometimes you'll see an asterisk in there for multiplication in some of your math. So I'm going to go ahead and take that multiplication sign, and I'm going to put it right here. And then now let's look at a to the fourth. A to the fourth means a times a times a times a. We have four a's being multiplied by themselves. That's a to the fourth. Well, since all this is multiplication, can't we kind of simplify this a little bit to make this a to what power? 1, 2, 3, 4, 5, 6, 7. We're actually multiplying 7 a's by themselves. So if we look, a cubed times a to the fourth is going to give us a to the seventh. If we look here at the next one, a cubed is going to be a times a times a. There's the asterisk, so we're going to put the multiplication sign there. And b to the fourth is b times b times b times b. There we go. And if we notice here, up here at the previous one, they were all a's. But this one here that we're working on now, they're not all a's. We just have a cubed times b to the fourth. Now you can put the multiplication sign in between there if you want, or you don't have to because they are because when we write it like I just wrote it there on the right, if I don't see an operation sign there, we know it's multiplication. So basically, a cubed times b to the fourth is just a cubed times b to the fourth. They do not have the same terms, so you cannot combine those like we did in the first example. All right, the first example showed us how to do it with variables. The second example, 4 cubed times 4 to the fourth. You could say 4 cubed is 64, and 4 to the fourth is going to be something like 64 times 4. $256, I'm thinking. So you could say we have 64 times 256, and then you have to multiply that out. But really, what we have is we have 4 times 4 times 4. That's 4 cubed. The asterisk or the multiplication sign there. And then 4 to the fourth. So how many 4's are being multiplied here? 1, 2, 3, 4, 5, 6, 7. There are 7 4's being multiplied. So 4 cubed times 4 to the fourth is equal to 4 to the seventh. And at this point, 4 to the seventh, that would benefit us by, we're probably going to have to type that in the calculator, or at least most people will. That's going to benefit us because we only have to press like you know, 2 or 3 buttons in our calculator, whereas 4 cubed times 4 to the fourth, there's more buttons to press, and with more buttons, more of a chance for an error. Um, 16,384 will be the answer there. So that one there, the first one, you're going to reduce a to the seventh. The second one, you're probably going to see it like here on the right more times than you'll see it on the right. And then the third one, 4 to the seventh, which is 16,384. You should go ahead and multiply those ones out where there are numbers there. Let me see what's on the next slide here. There's a certain rule that you can do to make this a lot quicker than actually doing this right here and laying out all the A's and then figuring out how many of them you're multiplying. If we look at these numbers here, if we have 3 and 4 to get 7, what do? Well, we add them together. So if they have the same base, A and A as the base, they have the same base, and you just add those exponents. Now look down here at the second example. Do they have the same base? A and B. Those are not the same base, and that's the reason why your answer looks like it does out here. But if we look down here at the third example, base 4 and 4, they do have the same base, so then we can add the exponents. 3 plus 4 will give us a 7. So the base is 4 to the 7th power. Let's look at this next example. This is real helpful when we multiply scientific notation, among other things. But scientific notation, since it's all multiplication, we have some numbers here. The commutative property will allow us, the commutative property of multiplication will allow us to rearrange these. So we'll say 3 times, and I'm going to put the 12 next to that. And then I'm going to say times 10 to the 8th, and then times 10 to the 4th. So basically we have 3 times 10 to the 8th times 12 times 10 to the 4th. Those are some fairly large numbers, which we could do this without a calculator. Commutative property, put things together. 3 times 12 is 36. Since this is scientific notation, I'm going to use the X multiplication sign. And 10 to the 8th times 10 to the 4th. Well, we know they both have the same base of 10. So it's going to be 10 to what power? Well, if they have the same base and you're multiplying them, you just add those exponents. 8 and 4 make 12. So we have 36 times 10 to the 12th. Now, this is not scientific notation, because scientific notation, well, actually that was not scientific notation either. Scientific notation says we're supposed to have 3.6 times 10 to something. And if we took the decimal place from here in 36 and we moved it one place to the left, that raises that exponent 1 power. So there's the solution, 3.6 times 10 to the 13th. What is this called? This actually does have a name. This is called the product of powers property. If you have a raised to the m power times a to the n power, that's going to equal a to the m plus n power. And we notice they have the same base of a. The product of powers property. If you need more time, pause it. I'm moving on to the next slide. Right here. Here's a few examples. I want you to try and work those out. The third example down on actually both of them, it just says x times x to the 7th. You have to remember what power is with the left x. what power is right there. If you don't see a power, it is there. Um, so think about that. If you don't know, listen to my explanation. I'll explain that. I want you to try and work these out. The ones on the right, after you have simplified those to, say, 3 to the 5th power, I want you to go ahead and multiply those out and tell me what that is. So go ahead and try these 8 and then check your solutions. So go ahead and pause the video. M to the 5th times m to the 8th, they have the same base. So it's going to be m to the 13th. 5 plus 8 is 13. T to the 10th times t to the 12th. They both have t for a base, so it's going to be t to the 10 plus 12 is 22. X times x to the 7th, they both have the same base, and we know when we just see the x on the left that it's a power of 1. So now we know 1 plus 7 is going to be x to the 8th. And the last one, g squared times h cubed, g and h, they are not the same base, so you cannot do anything with those exponents. What they gave you for the problem, or what they told you to simplify, was the answer. Looking here on the right side, 5 to the 6 times 5 cubed, they have the same base of 5, and 6 plus 3 is 9. 7 to the 1st times 7 squared, they have the same base of 7, add the exponent, 7 cubed. And then on the bottom, 10 cubed times 2 cubed, they do not have the same base, so you cannot do anything there. So now we need to come up with solutions here. If you couldn't come up with those solutions, don't forget, most of you are on a computer. Most computers do have a calculator there. 3 raised to the 5th power is 243. 5 raised to the 9th power is a fairly large number. 1,953,125. And 7 cubed, 343. And the last one, we know that 10 cubed is going to be 10 times 10 times 10, which is 1, and then there will be 3 zeros there. So 10 cubed is 1,000. 2 cubed is 2 times 2, which is 4, times 2 times 2, there's 2 2's, which is 4, times 2 again, which is 8. I put 3 tally marks to let me know that I had 3 2's in my multiplication. And this right here, 1,000 times 8, should be fairly easy enough for you. 8,000. So I do have a question here. Why did the chicken cross the road? I know that's a very challenging question. There are numerous answers to it, but one of the answers that I have is to prove to the possum that it could actually be done. That old possum, you just never know what he's doing. Is he out there taking a nap in the middle of the road, or did he try and take out a big old semi truck and knocked him out for a little bit or something like that? You never know about that old possum. He's a sly little creature. All right, different type of problem here. Instead of having one number raised to a power multiplied by the number with the same base raised to another power, And simplifying it, we now have a number raised to a power and then raised to another power. Just watch this and watch what's being done here. All right, so this is what we have. We have a cubed raised to the fourth power. So what number is being raised to the fourth power? If we look, a cubed is being raised to the fourth power. So that means we have a cubed times a cubed times a cubed times a cubed. This is a cubed to the fourth power. And now we know what a cubed is, right? A cubed is a times a times a. And a cubed is a, wrong color, a times a times a. And a cubed, a times a times a. And the last one here. I'm going to have to go with yellow again. So this is what we have. So if we notice, they're all a's, and they're all being multiplied. And we know if we have a bunch of a's being multiplied, we can just say it's a to what power? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. That would be a to the 12th power. Write that up here. A cubed raised to the 4th power is a to the 12th power. Let's look at the next example down here. 2 squared cubed. 2 squared cubed. Well, what number is being cubed? That would be 2 squared. So that means we have 2 squared multiplied by itself 3 times. And 2 squared is just 2 times 2. In the middle, 2 squared is 2 times 2. And the far right, 2 squared is 2 times 2. And we bring down our multiplication sign in between every single one of those. And so what do we have here? Well, we know they're all 2's being multiplied together, so it's going to be 2 to a power. Count them off. 1, 2, 3, 4, 5, 6. 2 to the 6th power. 2 squared raised to the 3rd power is going to be 2 to the 6th power. Can you figure out what the rule is here? If you have a power raised to a power, what are you supposed to do there? Well, if you look at the top example, we have a 3 and a 4 to make a 12. So that would be 3 times 4. And look at the bottom one. We have a 2 and a 3 to make a 6. Well, that's also multiplication there, right? So when you have a number raised to a power and then it's raised to another power, all you have to do is multiply the powers and keep the same base. See, the base was a 2 here. The base is still a 2. The base was an a there, and the base was still an a. The top example, the simplified answer is a to the 12th power. The bottom one, 2 to the 6th power, you should simplify it into a number and just say it's 64. Okay? So tell me this, why did the rubber chicken cross the road? Now think about it, rubber chicken, and not just the chicken, the rubber chicken. Why did the rubber chicken cross the road? Because she wanted to stretch her legs. That's a pretty good one, I thought. Rubber chicken, stretch the legs. You get it? You get rubber, stretch, legs? That's what I thought. Okie dokie then. The last thing that we just looked at right here, those two examples that you looked at, it's called the power of a power property. If you have a raised to the m power raised to the n power, the answer is going to be a raised to the m times n power. So here's some problems here. See if you can work these ones out. Actually, I just want you to do these three and try these two. You can try the last two, but I will help you out on the last two. So if you just try those five real quick, and then I'll go through the last two fairly quickly. So go ahead and pause the video, work them out, and then check your solutions. All right, if we look on the left side here, we are simplifying. H raised to the fifth power raised to the seventh. Well, we know it's going to be h, and what's 5 times 7? 35. H to the 35th power. The next one down. P raised to the 15th power raised to the third power. Well, we know we're going to have P, and what is 15 times 3? That's 45. And the last one, W to the 40th power raised to the 10th power. Well, we know we're going to have W, and what's 40 times 10? 400. Okay, on the right side, 5 raised to the 4th power raised to the 5th power. Well, we know we're going to have 5, and what is 4 times 5? 20. And 5 to the 20th power, I believe, is going to be a fairly large number. If you change this, it's going to be approximately 9.54 times 10 to the 13th power, approximately. And the next one down, we're going to have -3 raised to the third power raised to the 10th power. Now remember, we're raising -3, so we have to put it in parentheses because we got to make sure the negative sign stays with the 3. So you put -3 there. -3, and what about 3 times 10? 30. If we look here, -3 to the 30th power. It's also a fairly large number. It's approximately 2.1 times 10 to the 14th power. Now you notice it's a positive answer, and that goes because if we look here, let's look at -2 squared. -2 squared is -2 times -2, which a negative times a negative makes a positive answer 4. Now, what was being squared here? Well, -2 was being squared. If we look at this problem here, what number is actually being squared? Well, +2 is being squared. We have the negative sign, and then we're going to have 2 times 2. See, up here in this previous example, the negative sign is grouped with the 2 by parentheses. Down here in the example we're working with, the negative sign is not grouped with the 2. It's just sitting out to the left. You follow your order of operations. You do your exponents first. So that's why we have 2 times 2. And then that makes a 4. And then you drop your negative sign down. So that's the difference there. That's why I told you to put the -3 in parentheses. Okay, let me leave that example there. Let's look here. -3. Nope, not -3. Just kidding. Haha. About as funny as the last joke, right? I thought it was. Stretch, rubber, chicken, stretch, legs. Oh my, that's good times. All right, so if we look here, negative 2 raised to the third power, negative 2 times negative 2 times negative 2. If we have a negative times a negative, that's going to make a positive, and then that positive number times the negative will give us a negative answer. 2 times 2 times 2 is 8. So the answer is negative 8. If we look here, if we have negative numbers raised to a power, if they are even exponents, the answer is going to be positive. If we have a negative number raised to an odd exponent, the answer will be negative. So that's just kind of a side note there you should pay attention to when you're using your calculator to do negative 3 raised to the 30th power. You should have put that negative 3 in parentheses. That way you would have gotten the positive answer. All right, let's look at the next example down. It says x plus 2 raised to the third power, and then all of that is raised to the fifth power. Well, just because it says x plus 2 doesn't mean that it's any different than negative 3 or over here, w. X plus 2 is still going to be the base, and what do you do with those exponents? You multiply them. And you have to put x plus 2 in parentheses because you have to put it in parentheses because there's a plus sign there. You're trying to keep x and 2 grouped together with the addition sign, so you put the parentheses there. And the answer to the next one, just because we had a bracket here and we have a parentheses here, doesn't make these any different problems. Some people will use parentheses and some people will use brackets and parentheses. So x plus 2 is being raised to the third power and the fifth power. They look a little different from the very beginning of the problem, but the answers are still the same. You should be aware that brackets do the same thing as parentheses. Okay, that would be power to a power property. Why did the Roman chicken cross the road? Now, this one here might take a thought. Why did the Roman chicken cross the road? He was afraid someone would seize. Wait, I gotta start that one over. I messed up for you. Why did the Roman chicken cross? Erase that last like 10 seconds out of your memory. You got it erased? Okay. Why did the Roman chicken cross the road? She was afraid someone would seize her. She was afraid someone would seize her. There's a pun on words. Roman chicken, Caesar, Roman chicken, Caesar, there. She was afraid someone would seize her, so she crossed the road so no one sees her. Like, that's pretty funny. Pretty funny. Roman chicken, Caesar, that's hilarious. Hilarious. Whoa, what is this? This doesn't look like these problems here. There's only one variable or one number in there. Now there are numerous. If we look here, this one had x and 2 separated with the plus sign. This one here has 10 and 5 separated with the multiplication sign. If it's separated with the multiplication sign, we can do this next property. If it's separated with the plus sign, you cannot do this next property. This is your solution here. So multiplication sign, it's the power of a product property. And so what does this mean? The power of a product property, it means that we're going to have, let's look here. What number is being raised to the fourth power? Well, that's a times b, right? Times a times b times a times b, and then times a times b. We have 1, 2, 3, 4 ab's being multiplied by themselves. And if we look, what is between a and b? Multiplication, 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 multiplication. So therefore, we have commutative property that allows us to put the a's together. It also allows us to put the b's together. Since there's a bunch of multiplication signs there. And so now we have a to what power? A to the fourth, and b to the fourth power. So this is the solution. Now, if we look at this next example is a power of 10. That means we're going to have to write what we have inside the parentheses 10 times. And that's not much fun. That takes up a lot of our time. There's a way to do this. This saves a lot of time, and therefore that's allowing us to go and learn more. Why did the chicken cross the road? Jokes. So, or the Roman chicken, or the rubber chicken, or whatever type of chicken you're talking about. So what is the property here? Well, if we look, we have A has the power of 4, and B has the power of 4. And this right here was a power of 4. So basically, if it's multiplication inside the parentheses, you can take that power of 4 and put it with everything. It has to go with everything inside, and it's only if it's multiplication. Now, a lot of you think this is similar to the distributive property. It's not the distributive property. It looks similar, but it's not. Okay. So how do we do this? Let's look at the next example. Since we have multiplication in there between x, y, and z, we're going to put the 10 with the x, the 10 here, and the 10 there. Let me erase the previous example here for you. If you need it, pause the video and write it down. If not, okay, so let's look here. So we're going to have x, and that's going to be to the 10th power. We're going to have y to the 5th power raised to the 10th power, and we're going to have z to the negative 4th power raised to the 10th power. Now, the last property that we learned said if we have y to the 5th raised to the 10th, well, what do we do with 5 and 10? We multiply them. And if we have z to the negative 4th raised to the 10th, that's going to be negative 40. Negative 4 times 10 is negative 40. Now, what is the exponent here with x? That's a 1. So x to the 10th power. So simplifying here, basically what you do is you take this exponent of 10 and you multiply it with all the other exponents, and you'll get your simplified answer. We have an exponent of negative 40 there. Typically we don't like negative exponents. Sometimes we leave them like this, but most of the time we will we'll change them. Working with zero and negative exponents, that's in the next lesson. So we will we'll touch on negative exponents in the next lesson. You'll know what to do with that negative exponent when you get to it after the next lesson. And let's look at the last example here. The last example says we have 10 times 5, and all that's squared. Well, you know 10 times 5 is 50, and 50 squared is something you could probably figure out. But 50 times 50 is a fairly large number. It's an easy number to multiply by in your head because they are, well, let's just say it is. So we have 10 to the first power, and we're going to be raising it to the second power. So that's going to leave us with 10 squared. And then we have 5 to the first power raised to the second power, so that's going to be 5 squared. 10 squared we know is 100, and 5 squared we know to be 25. And so therefore 100 times 25, 2,500 or 2,500. So knowing this property allows you to work with manageable numbers. 100 times 25, I think, is a little easier number to multiply than 50 times 50, even though I think both of them are fairly easy to work with. So those are 3 examples on how to simplify when you have the power outside of the product of numerous numbers. When you're multiplying numerous numbers in parentheses, then you have a power outside of that parentheses. That property is actually called the power of a product property. And you can see if you have a times b raised to the n power, the power of n goes with a and the power of n goes with b, and you still multiply. So let's look here. Let's see if you can go ahead and do these 4 examples. Try and do these 4 examples. If you think about it, somebody asked George Washington one time, why did the chicken cross the road? And George Washington replied and said, actually, it crossed the Delaware River with me back in 1776, but most history books don't reveal that. He bunked with a chicken during his stay there. So keep that in mind. The answer to why does the chicken cross the road is a little different for everybody, even very important historical figures, such as old George Washington. Go ahead and pause the video here and see what you can do. See what you can do. Want to work this out? I know we have powers of 1 there, so 1 times 3 is going to be 8 to the 3rd, and 1 times 3 is 5 to the 3rd. I know 5 times 5 is 25, and times 5 again is 125. 8 cubed is going to be 8 times 8 is 64, and then times 8 again, 512. And if you take these 2 numbers and multiply them, you're going to get 64,000. The example down here at the down below, it is 10 to the 1st and b to the 1st. So 10 to the 1st raised to the 4th, so that is going to be 1 times 4 is 4. A squared raised to the 4th, 2 times 4 is 8. B to the 1st raised to the 4th is b to the 4th. 1 times 4 is 4. And the last one, c cubed raised to the 4th power, that's going to be c, and 3 times 4 is 12. Now, we don't want to leave it like this because we can work with 10 to the 4th. So 10 to the 4th power is 10 times 10 times 10 times 10, which means you're going to have 1 with 4 zeros. So that's 10,000. 10 to the 4th is 10,000. A to the 8th, B to the 4th, and C to the 12th. So there is your simplified version of the problem. All right, in the top right, we have negative x to the 1st power. And so now we're going to raise that to the 2nd power. So that's going to give us negative x squared. Remember, the negative sign is there with the x. It's grouped by the parentheses. And now we have y cubed, and we're going to square that. So 3 times 2 is 6. And so now we can simplify some things here. If we have negative x times negative x, that's negative x squared. So negative times a negative is going to give us a positive, and then x times x is x squared. And so our simplified version is going to be x squared y to the sixth. And that is your simplified version of this problem. Remember, you always should be paying attention to your negative signs, see if you could work with those. Now, if we look at the last example here, the negative sign is outside of the parentheses. So the negative sign is outside of the parentheses. That's important. We still have x to the first power, so x to the first power raised to the second power is going to give us x, and 1 times 2 is 2. And then we have y to the third power, and we're going to raise it to the second power, so that's still going to give us y to the sixth power. And remember what I showed you earlier, the negative sign was outside the parentheses, so we're going to put the negative sign, outside of all that we just calculated, and that we just simplified. Now, up here, negative x was in parentheses. Down here, x is not in parentheses. It's just x is being squared, not negative x. So therefore, there's no simplifying here because x squared is just x squared, and the negative sign is still there. So this right here is your simplified answer. You have to pay attention to what is being grouped together. Pay attention to the parentheses. I believe somebody asked Julius Caesar one time. Now remember, Julius Caesar. They said, "Hey, hey Julius, why did chicken cross the road?" And Julius said, "Chicken crossed the road to come, to see, to conquer." That's why the chicken crossed the road. And it was said. Look here. It says, "Welcome to the gauntlet." We have two rows of problems. So I want you to try those 2 rows. This puts everything, all 3 of those properties that we just learned, puts them all together into one problem. And from there, we're going to work on this. So go ahead and see if you can simplify those and work that solution out. Come up with the simplified version. Pause it, and I'll work these out. Okay, let's look at the first one here. The first one that says mn squared. I know both of those have a power of 1, so if I say 1 times 2, I'm going to get m squared times n squared times, and then I drop down n to the 4th. They have the same base, so n squared times n to the 4th, same base, and what do you do with those exponents? You're going to add those exponents. And then we bring down m squared with it. And so this right here is the simplified answer. M squared n to the 6th. Let's look at number 2. Number 2, let's use the commutative property to rearrange some things. We're going to put 2 and 5 together because we can multiply those. And then we're going to put x cubed times x to the negative 2nd power times x to the 5th together because they all have the same base. So 2 times 5 will give us 10. And if they all have the same base, what do we do with those exponents? We add those exponents. So 3 plus negative 2, 3 plus negative 2 gives us a positive 1, and then positive 1 plus 5 will give us 6. So we have x to the 6th power. And this is the solution. 10 times x to the 6th power. this example number 3. Well, let's go ahead and do this, where you put the exponent of 3 outside with everything inside. So it's going to be negative 5. I'm putting negative 5 inside parentheses. We know m has an exponent of 2, so 2 times 3 is 6. N has an exponent of 4, so 4 times 3 is 12. We're going to multiply by negative m squared and times n. Now, if we look, this negative sign, I want to deal with this negative sign. The negative sign is not with m. The negative sign is outside of m. So we're going to take that negative sign, and it gets moved first. It does get moved first. Okay, now let's work with negative 5 cubed. Negative 5 cubed, well, this is what we have. We know negative times a negative times a negative will give us a negative answer. Negative times a negative is positive, and that positive times that negative is a negative. That's why we get a negative. 5 times 5 is 25, and times 5 again is 125. So we have negative 125 in parentheses there. Now, if we're looking, like we did down here, we can rearrange m and n, or you can think about it in your head. I have m to the 6th times m squared. They both have m as a base. So what do you do with those exponents? You're going to add them. N to the 12th times n to the, what power is there? First power. So n to the 13th power. And it's important for us to remember that we pulled that negative sign out front, and that's going to change some things here, because we have a negative outside, a negative times this negative inside makes it a positive 125. And these are all the same there. M to the 8th and n to the 13th. So that'll be your solution there, your simplified version of number 3. And number 4, let's look at what we have here. Number 4, well, 3 to the first power raised to the third power, so the 1 times 3 is 3. And then h and 2 times 3 is going to be 6. This h here has the exponent of negative 4 with it. So those are all multiplication signs. Multiplication, multiplication, we're all multiplying there. So 3 cubed, 3 times 3 is 9, times 3 again is 27. H to the 6 times h to the negative 4. Well, they have they have the same base of h. So what do you do with those exponents? You will add those exponents. 6 plus negative 4 will give you 2. So your answer to number 4, simplified version, 27h squared. 27h squared. And I will leave you with this last thought here. Why did the chicken cross the playground? Why did the chicken cross the playground? This one should be obvious, of course. The chicken crossed the playground to get to the other slide. He crossed the playground to get to the other slide. Oh my. Cracks me up. Okay, well, I hope you guys have learned a little bit here from your multiplication properties of exponents. If you have any questions, let me know. We'll see you at the next stop.